Okay, Roger, Mud Fossil University, going to relate a little of my experiences to these experiences. So, this is about dinosaur soft tissues were found by Mary Schweitzer and another fellow that worked for her. And it apparently gives more proof to creation in Bible stories than evolution. So they fired the guy that did the technician. He fired him. He got a lawsuit and collected some money. She's still on the outs as far as I know. And here's what happened way back when this was done. It's got to be 10 years ago, somewhere in that area. And she was the first person I contacted. And at this point, I think she was trying to hang in with academia, but she never got back in, as far as I know. And she was not very nice to me either. So she wanted to stay amongst that crowd. It appears she wanted nothing to do with me. Still doesn't. And I could support her and help her, but I don't know what to say. It's what it is. I'm just reporting the facts. Here goes.
What happened next happened by mistake. Mary put some fragments of the bone in acid to dissolve away the outermost layer of mineral. But the acid worked too fast.
I just want to kick in here and say that this, I think it was this guy, I think his name was Jack Horner. He was cutting, he had a huge dinosaur bone. They couldn't get it out of there, so they cut it in half to get it out. And they had a whole bunch of little scraps left over. They gave it to her. So here's what she did. Let me start again. She put them in acids, I forget the chemistry. Just listen to what happened.
To dissolve away the outermost layer of mineral. But the acid worked too fast, and all the mineral dissolved away. Being a fossil, there should have been nothing left. But there was, and it was elastic, like living tissue.
This is the piece.
No. She showed us video she took under the microscope.
That's really what happened?
Yes.
That's the dinosaur bone?
Without
You could do that all day long. This is nothing special.
mineral now. That's what was left.
It looked like the soft tissue she would have expected to find if it had been modern bone. This was impossible. This bone was 68 million years old.
I just want to tell you something. These dates are ridiculous. Absolutely ridiculous. And I have evidence to support every word I say, and they have nothing to support the words that they say. That date is about 4,300 years ago. All these things were drowned in a great cataclysmic flood. And Velikovsky did all the research on this. It was recorded. This is not something that is unknown. It's not even can be disputed when you start to go into the KT layer, which is all kaolin clays, which is skin clays, and loaded with iridium, which is also from the skin. Dave Hudson had samples taken of arterial giant blood flows, and I know they're arterial. He didn't know it. He was having it tested because it was loaded with transition metals, which are platinum group metals. He found tons, literally 2,300 ounces of these platinum group metals in this blood flow, which was an arterial blood flow, probably right out of the heart somewhere, coming out of the side of a mountain. He describes the whole thing from a hot springs area, and it was causing trouble with his crops. So he had this brown goop analyzed, and it was loaded with all these platinum minerals, which are the gold and the silver and the copper and all that stuff that is in your blood. All right? So he gets it analyzed, and when they came back, the analysis was over 5% was this iridium. They say, oh, it only comes from outer space. No, it doesn't. It is in you. It is in your skin primarily. And that is the stuff that eroded was kaolinite clays and this iridium. That does not come from outer space. And that is a coating around the world everywhere. And it happened 4,300 years ago, as was recorded during the Great Flood. So it's time to fess up and start looking at this and stop being so stubborn in the academic communities. They have really shown their stripes.
You see this and you think, what? You
I didn't want to tell anybody.
Yeah, of
You'd be
course
ridiculed,
not. Yes.
right?
And
she
so
did.
I said to my technician, okay, do it again. I don't believe it.
And yet, in sample after sample, they were there. Things that looked suspiciously
I have thousands and thousands of samples.
like flexible, transparent blood vessels. she finally mustered the courage to tell Jack.
She said she dissolved the bone away and there were blood vessels. And
I'm going to tell you something now. This guy's not talking about it anymore. I think he's still in amongst the, but he didn't, he published with her, but she's the one that got vocal. And as far as I know, I think he's still in amongst and, still talking about his 68 million a year old dinosaurs.
I was like shocked. I mean,
How could that be?
How could that be? That's right.
The things Mary was finding inside dinosaur bones,
Look at that.
blood vessels, and even what seemed to be intact cells,
I got blood gushing out of the ones I have here, literally dripping.
pose a radical challenge to the existing rules of science, that organic material can't possibly survive even 1,000,000 years, let alone 68 million. Mary, Jack, and their team published their B-Rex findings in a series of papers in the journal Science and were promptly attacked. Critics said their samples might have been contaminated, or that the supposed blood vessels were actually something called biofilm, a type of slime. But as Mary showed us, she's been able to replicate her findings. These are pieces of an even older dinosaur, a well-preserved 80-million-year-old duckbill. When she dissolved it away in acid,
Let's put this under the scope here.
well, look, is that a blood
This
vessel?
is a blood vessel.
You're
You
kidding.
see the branches right there? And look at all of them. And it's so consistent over and over and over again. We do this bone and it comes out and I get excited every time. I can't help it. I mean, 80 million years old.
No,
Mary
it's not,
published
first
her
of
new
all.
results last year, and while some of her critics have been swayed, the controversy still rages, and the stakes are high. If blood vessels can survive 80 million years, what about DNA?
All right, I'm going to show you a quick selection of mud fossils. That's a mud fossil bone head. That's the head of a bone, and that right there is where the ligament would attach, and all those little tiny holes inside of there are where the ligament anthesis point is. Now, that there's blood vessels go in, the nerves go in, there's bone foramens. This has the entire fabric wrapping around it. It's called the tunica. You see that triangular look there? This, and back to here. It wraps right around there. And that's what protects this, so that it doesn't get destroyed in your body, because they can't be in the salt solution of your body, believe it or not. The membrane keeps them in a different environment. Once they were in this salt solution, they transition. And there is one little tiny spot. I don't know if you'll be able to see it even. You see that little bitty piece of bone there, right at the very bottom? I think it's right there. Almost impossible to see. That's all that's left of this as far as bone goes. But it was obviously a bone. Now, I'm going to show you some lungs. This is a lung right here. That lung was DNA certified. That's the pleura of the lung. That pattern, any autopsy guy will understand. That is the pattern of the lobes of the lung. That is the depression of the heart. That is the left lung. That's the depression of the heart. This is a human lung. That's at the bottom where it tags in, and I drilled inside of there and got blood right from the bloody spot. Now that's a lung that has all of its pleura on there. Now here's a lung that is partially decayed, and you can see into, you see the lung part there, and that fabric there, that's the pleura that I showed you on the other one. Inside is the red lung. That's the red fleshy part of the lung that transfers the gases. And this has started to push its way off, the pleura. Now guess what? I have another one here that's all the way down to where that pleura has completely gone. There's this one here, and I'll put a little water on there, and you'll see it turn red. It's been years that it's been like this, so it won't get too much red, but it comes out pretty quick, and it shows pretty obvious where the red is. Now, that is the blood, and this was another lung, just like the other ones, only this one is all the way down to this matrix of cellularness. You see all those little keyhole looking things. You see the blood leaking. The guy died just like this, and the blood leaked down to the bottom of his lung. I had a doctor call me and say, yeah, I know how he died. And I said, yeah, I know too. So there's that one. Now, let's see another one that was in a condition that was not like those. This was in probably a volcanic acid condition. And it ate into all the organics and left just the fabric of the cellular material. There's some, you see the red? That's blood, the red there. You see that little crystal there? That's what they do. They form crystals in these vugs. These are vugs, these holes. And in certain cases, they form really elegant, well, diamonds and everything else. So that is another law. Now, so there's some fossils. Now, what is this? That's a goose head. You say, oh no, Roger, that can't be a goose head. Absolutely, it's a goose head. And there is the pattern of the feathers on the goose's head. You see that? See the pattern? This is his neck, right in the back. He died laying like this. This is his eye, and a little beak. All right, so that is a mud fossil. The guy died like this. The thing died like that, and laying flat. And they were soaked. Everything was soaked. Everything I'm showing you was soaked. Now, so these are body parts. I'm going to show you something else, which these are what I call mud fossils. I named them when I originally discovered them. And what I'm going to show you next is a mush fossil. Okay, you should be able to see there's a layer of gray clay here and a layer of brown clay above it. So let's look at it when we tip it over. So it's actually, this gray clay is pushed down through a layer of brown clay. You see this? This was the layer of brown clay. So it was really up here. And when the guy stepped on it, gray clay was above, pushed it down through. So the gray clay is now down at the bottom. You see it? Of the brown clay. So, Triassic rock is gray clay, well, it's red bed, gray clay, which was up on top of the red bed. So it's red bed, gray clay, black cap. That's the Triassic. Red bed, gray clay, black cap. This is a human footprint. It's pretty obvious to see. And I've made molds of it. I have my foot in it, and I know it's exactly what it is. It is a human footprint. And all of these little pinchy looking things are what I would call suck-ups. And I did the same thing. I made this exact same stuff. And when you have a wet, slimy clay layer, and you go with your foot and you come up, you get these suck-ups. Now, you don't have them on the sides. You see over on the sides? A little different texture on the sides, because that's where your foot was not like flat. Those didn't have it. Center has it. All right, back out of there. You can see that stuff. All right, these suck-ups don't really go on the side like in the middle, because it's the guy's foot is not on the side as it is in the middle. Comes back up. Now that is the structure of a foot. I mean, trust me, that's what it is. You see that little thing up there, the little pinchy looking thing right there? That's where your foot, your big toe goes. Oh, you saw the Triassic goose. This is a Triassic human footprint. Now, when I say Triassic, you say, why is that? Because it is a red bed, which was this, and then a gray clay, which was above this and pushed down through it, and they happened at the same time. They were wet at the exact same time. And then a black cap came right on top of it, and that happened almost instantly after all three layers happened at the same time. And I can prove these statements. I'm not just guessing. All right, here's the gray bed, okay? And that would have been, this gray clay would have been above this and laying on top. The guy stepped on it, pushed it down through the red bed, and you can see it's quite obvious because the gray clay is now below that red bed, only where the footprint is. And then the red bed is where it should be here. Now, so that's the gray clay pushed down through the red bed. Now above this is the black cap. And that is somewhere over here it is. This is the black cap. You see the black here? See, let me back this up. That's the black cap. And this fit right on top of there. All three of these layers happened at the same instant in time. You cannot push gray clay in that manner through this red bed and then have this black cap not come right away. Otherwise, this would have eroded. The whole thing was wet. Case closed. Triassic is over.